In this video, we're going to look at dimension analysis. So in dimension analysis, we have to know the dimensions of certain quantities. And after knowing the dimension of those quantities, we can derive the dimension of whatever quantity that we might be given. So first, let us start with looking at these quantities. These quantities whose dimension we have to know are length, mass, and time. Length is measured in meters, mass is measured in kilogram, and time is measured in seconds. The dimension for length is L, or can just be written as this. The dimension for mass is this, or can just be written as this. The dimension for time is this, or can just be written as this. So these are the three dimensions of these three quantities that we have to know. And from these dimensions, we can derive the dimension of whatever quantity that we might be given. So for example, let us write the dimension for velocity, and here we'll write the dimension for acceleration. So velocity, as we know, it is measured in meter per second. So meter per second are the SI unit for velocity. So we are going to write the dimensions for velocity instead of the SI unit for velocity. So we're going to rewrite this as meter over second. This and this, they're just one and the same. So velocity is equal to, so this SI unit meter is for the quantity length, and the dimension for length is what? Is L. So instead of writing M here for meter, we're going to write L over S. S is the SI unit for the quantity time, and the dimension for time is what? Is T. So we're going to write over T. So velocity is equal to L. Now, writing T at the numerator, we're going to multiply the power of T with a negative. So we're going to have T to the power minus 1. So this is the dimension of velocity. It can also be written as velocity is equal to L to the power 1, T to the power minus 1. It's just one and the same thing. Or if you want, you can write it as V is equal to M to the power 0, L to the power 1, T to the power minus 1, including all dimensions of the three quantities. Because M to the power 0 is just mean that here we have 1, meaning this, and this are one and the same. Let us look at acceleration. So acceleration is measured in meter per second squared. So step number 1, we're going to rewrite this in form of a fraction. So we'll have meter over second squared. And then step number 2, we're going to write the dimensions instead of the SI unit. So the SI unit meter has the dimension L. The SI unit second has the dimension T. But since S is squared, we're also going to square T. So acceleration is equal to L. Writing T squared at the numerator, we're going to have T to the power minus 2, because when we write it at the numerator, we multiply the power with a negative. So it can be written as this, or we can write it as acceleration is equal to L to the power 1, T to the power minus 2, or we can write it as acceleration is equal to M to the power 0, L to the power 1, T to the power minus 2. It's just one and the same thing. Let us look at the dimension of the quantity force, which is force is equal to ma from Newton's law of motion, where m is mass and a is acceleration. So force is equal to, we're now going to write the SI units for these quantities here, which is mass and acceleration. So what are the SI unit for mass? So the SI unit for mass is kilogram. The SI unit for acceleration is meter per second squared. So we're going to write this part in form of a fraction. So we're going to have kilogram times meter over second squared. Now, on this step, we're going to write the dimensions instead of the SI units. The dimension for the SI unit kilogram is what? Is M, multiplied with the dimension for the SI unit M, which is meter, is what? Is L, over the dimension for the SI unit S is what? Is T. Now, since S is squared, we'll also square T. So force is equal to M L. Now, writing T squared at the numerator, remember we multiply the power with a negative. So we're going to have T to the power minus 2. Can also be written as M to the power 1, L to the power 1, T to the power minus 2. It's just one and the same thing. Let us look at the dimension of the other quantity, momentum. So momentum is equal to mass times velocity. So we're going to write the SI unit for the quantity mass and velocity. So mass has the SI unit kilogram, velocity has the SI unit meter per second. Momentum is equal to kilogram meter over second. So now in this step, we're going to write the dimensions instead of the SI unit. So the SI unit kilogram has the dimension M, the SI unit M has the dimension L, and the SI unit S has the dimension T. And now we're going to write T at the numerator. We know that we have to multiply the power with a negative. So we're going to have T to the power minus 1. So this is the dimension for momentum.